Assalamualaikum, brothers and sisters.
Waalaikumsalam, sir.
Oh, yeah, there.
Sir.
Okay, great. Shall we start, sister?
Yes, sir.
Okay, your voice is better than the majority. Okay, since I take it as a voice of the majority, let's start our day. Let's start our day with the recitation. Okay, I give salam one more time. Assalamualaikum warahmatullahi wabarakatuh. Let's start our day with the recitation of Ummul Kitab Al-Fatihah. A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin arrahmanir rahim maliki yaumiddin iyyaka na'budu wa iyyaka nasta'in ihdinas siratal mustaqim siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin amin. Okay, let's start our day with a dua led by Ustaz Harith. You are there, right? Ustaz, tafadhal Ustaz Harith.
Yes, Doctor.
Yeah, tafadhal. Now your turn. Bismillah.
Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Wassalatu wassalamu ala ashrafil anbiya'i wal mursalin wa ala alihi wa sahbihi wa barik wa sallim. Allahumma alhimna ilman na'rifu bih awamiraka wa na'rifu bihi nawahiyaka warzuqna. اللهم بلاغة فهم النبيين وفصاحة حفظ المرسلين وسرعة الإلحام الملائكة المقربين وأكرمنا اللهم بنور العلم وسرعة الفهم واخرجنا من ظلمات الوهم وافتح لنا أبواب رحمتك وعلمنا إسرار حكمتك يا رب العالمين اللهم افتح علينا حكمتك وانشر علينا من خزائن رحمتك يا أرحم الراحمين ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار صلى الله على سيدنا محمد وعلى آله وصحبه وبارك وسلم والحمد لله رب العالمين.
Amin ya rabbal alamin. Shukran Ustaz. Okay, let's continue from what we left last class. Remember last class we did scheduling using CPM. What is CPM? One more time. Critical path method. Now we are going to use PERT, Project Evaluation Review Technique. What's the difference again? Can we recall our project? What is CPM? Deterministic method. Another one, PERT. Anybody can recall? Probabilistic method. Remember? No? Yeah.
Yes.
So what is deterministic? The deterministic, if we refer to this house, sister's house, I do not know which sister. If we ask the activity duration, they can tell you exactly from their experience. Today, we are going to look from another perspective. If we were to ask for the activity time, because of lack of experience or the project is new, we cannot specify the activity duration. Maybe we allow for certain pessimistic approach. If everything is not in order, it will take longer time. If things are fine, everything are fine, it takes shorter time. Taking into account both, maybe we have another, what you call it, another time. Okay, let's look at it. So PERT, we always use when we are not sure about the project, or you have difficulty in estimating the activity durations. Maybe, as I said, the project is new to you, or maybe you have similar project, but in different set of environment. So it's difficult to estimate the time. Or another one, not much experience before that, and you are taking up the project. So it is normal or customary to put the completion time or activity duration based on what we call it optimistic time. And then another one is pessimistic time and most probable time. So we try to, every activity will specify 3 numbers. Optimistic activity durations, that means the minimum time an activity can be completed, that means everything goes fine. Or pessimistic, if things are not right, we take longer time, things may go wrong, we allow certain approach, certain consideration of other things, other thing not going right. So we refer as pessimistic activity time. And then we have normal time after taking into account things may go right or go wrong. We call it most probable activity time or activity durations. And these are labeled as A for optimistic activity time, then B for pessimistic activity time or activity durations, and then M for most probable activity time. And since it is probabilistic, the activity duration follow what we call beta probability distribution. This is an example. It looks like a whale or skewed distributions. Skewed to the right or left, this one? Skewed right or skewed left?
Right.
Right. Somebody say left. Majority say right. For the Malay, see the lepe, you know, lepe, this is horizontal lepe. If lepe on the right, it means it's skewed to the right. So the activity duration follow this beta distributions. Let's say the upper one, the vertical axis probability, and then across here activity time. The shortest time to the left is shorter time, to the right is longer time. On the left hand side, we allocate what we refer as optimistic activity time A. That means very short durations. And then we also allocate another longer period. We call it pessimistic activity time, B, A, B. Then we have mode, MODE, mode. I think you know mode, the most frequent occurrence mode. If normal distribution, we have mean in here, we call it mode. Yeah. So we refer to it as most likely or most probable activity time. We represent it as M. So we are given 3 sets of activity durations. Our job is to calculate a single number. We are not going to prepare a network based on optimistic, pessimistic, most probable. We are not going to prepare 3 sets of network diagram. Otherwise, we get confused which one to use. So we are going to use a single number. We call it expected activity time. Expected duration or expected time or expected activity duration T. And we are going to calculate this T. T equals A plus 4 times M plus B and the whole thing divided by 6. So for our purpose, we divide by 6. If you look at other texts, some use different number of this one, some use 3. They have different statistical basis. And then the spread here, we also have variance. Variance, we calculate with this formula, the variance B minus A divided by 6, the whole thing squared. B minus A over 6, the whole thing squared. Okay, that's the principle. Now let's have a go. This is what we have done. T, mean probability distribution or expected completion time. T, variance. This is the formula for variance. B minus A over 6 squared. Okay. Let's look at an example. You have been assigned as a project manager for a project for your company. This type of project was not carried out before in your organizations, and you have identified 11 activities for the whole project. Furthermore, there are uncertainties in completion times for all the activities. So the following table show the activities, their completion times in terms of optimistic activity time, pessimistic activity time, most likely or most probable activity time, and also the predecessor relationship in immediate predecessors. So you are given this set of information. These are the activities, A to K, 11 activities. This is the precedence relationship, the predecessor for each activity on the right-hand side here. You are given optimistic activity duration, pessimistic activity duration, and most likely activity duration. What do we have to do just now? What did I say just now? Find
expected.
T, find expected time T. Find expected time T and find the variance of the activity duration. How does it spread, this activity durations? So I already have it done for you. So this is the activity time we have calculated for you. What's the formula? Expected time. A plus 4 times M plus B divided by 6. That's one of them. A, 8 plus 4 times 10 plus 12 divided by 6. Do you get this number?
Yes.
Yes. And then we calculate the variance. Where's the variance? Where's the formula? B minus A divided by 6 whole thing squared. 12 divided by 8. Sorry, 12 minus 8 divided by 6. Square it. You get 0.44. Okay.
Yes.
Yes. Maybe test another one. Let me choose which one. Okay. Test B, activity B. You have, what do you get? 5 plus 4 times 8 plus 17 divided by 6. 9. Okay. Take note. You see this 10 almost is, this 10 is equal to this M. You see expected time for activity B slightly more than 8 or M. The others exactly the same. Look like all are the same except the last one, 7. When you calculate this slightly more. So if you are in the exam, you calculate this is very close to M, then you are okay. This is self-check. If expected time, the number is very close to M, then you are okay. But if it is far out, that means something wrong in your computations. Okay, let's have a go quickly. I think we don't go into detail how to draw the network, how to find all those early start, early finish, assume done. So this is the network done for this project. Activity A, B, C, D, E, F, G, H, I, J, K, and finish. Then I already computed for you the slack. What does the slack represent?
Critical activity.
Critical. Which are the critical activities here? A,
with slack 0.
AE slash 0, G, H, K. So the critical path will be start A, E, G, H, K, finish. So this is the critical path. What's the total completion time? The total 36. 36 is the completion time. There are two here, 36, 36. So if you are doing this forward pass, now we want to go backward. Which one to use? Use 33 or 36? We take the longest one. Here 36. And backward pass 33, 36, 36, 36. So we use the longest one. So now let's calculate the variance for each activity. We already calculate. Now we want to add the variance of the critical activities. So variance for critical activities for A 0.44, for E 0.44, G 0.44, S 1, then K 2.78. What we are going to do, we are going to add this variance 0.44 plus 0.44 plus 0.44 plus 1 plus 2.78. So we add this. This will be the variance of the activity or of the critical path. The variance of the critical path. So we can say it like this. The critical path A, E, G, H, K, completion time 36 weeks. So the variance, if we add this number, assume it is right, 5.1. And then the standard deviation, 2.25. Okay, what does it represent? This is probabilistic approach. The completion time is 36. Are we going to get it exactly 36? Not likely. Reason? Because the activity duration here is an estimate, probabilistic estimate. So activity A, 10 is a probabilistic estimate. E, 10 also probabilistic estimate. Activity G, this 3 also probabilistic estimate. H, 5 also probabilistic. K also probabilistic. And then the variability, activity A, you have the variance 0.44. E also tend to vary according to this variance. G also can vary. S also may vary. K also can vary. So we may not have exactly 36, but the probable estimate will be 36 weeks. So what does it mean? So this is the same activity schedule. We skip this one. I think you are familiar with this from the previous class. So we have these critical activities, the completion time. This completion time will follow what we call it normal distribution, normal distributions. It will follow normal distribution. the whole project completion time, 36, follow normal distributions. The activity follow beta distributions. This 36 weeks represent the mean completion time, mu. And then the variance 5.1 represent the variance of this project completion time. So the variance 2.5. So the variance will be 2.25. Sorry, 5.1. And then we find the standard deviation for this one. So we have to find the standard deviations. So it can vary 2 to 2.5 weeks. Okay. Now we have this information. The project completion time, we said just now, follow normal distribution. What's mu? What's the mean? Mean is 36. This is the mean completion time for the project. Then we have the variance 5.1 and we have the standard deviations. If I were to ask you, what is the probability that the project will be delayed more than 36 weeks? Delay more than 36. I say the mean, mean is 36. What is the likelihood, the probability that the project will be delayed more than 36 weeks?
0.5.
0.5. How do you get 0.5? Because it's a normal distribution, 0.5. What is the probability that we can complete it earlier than 36 weeks? Earlier than 36 weeks. 0.5. 0.5 also. So what we can say here is we have 50-50 chance that the project can be completed in 36 weeks. I mean, it can be 50% maybe shorter, 50% probability it will be shorter, or 50% probability it can be longer than 36 weeks. So this is what this PERT represent. So now let's play around with this one. We have 4 scenarios. What is the probability of completing the project in 40 weeks? You don't look at the answer, we are going to answer afterwards. Another one is, what is the probability of the project completing in 35 weeks? Now we want to find out the probability to complete. Now, if we are happy with the probability, with say 98% chance or 90% probability of completing on time, what is the completion time? Or another one, with 40% chance of completion, what is the completion time? Okay, let's have fun. This is the first question. What is the probability of completing the project in 40 weeks? What does it say? Just now we say our project follow normal distribution. We have mean of 36 and then standard deviation of 2.25. What does it say here? Let's say we put here, the question say 40 weeks. Let's say X is the completion time, 40. In 40 weeks or within 40 weeks. That means less than 40 or more than 40?
Less.
Less. So we want to know how long, what's the probability of completing the project within 40 weeks? How to do that?
Use Z score.
Use Z. Remember this one? Remember this formula in statistic?
Yes, sir.
Z
Yes.
x minus mu over sigma. So x is known, mu is known, sigma is also known. So what are we going to do with this? So let's calculate z, x minus mu. X is 40, mu is 36, sigma is 2.25. We have this number, z 1.77. So what do? We are going to find from the normal distribution table. Okay. Let's look z from the normal table. Z equals 1.77. Let's look at it. 1.77. Which one to look? Look inside. For this particular one, we are using this text, the latest textbook, edition 2019. We are using this table. Yeah, maybe you are familiar, all the numbers inside here, less than 0.5. For this one, for our purpose, the number inside here, the probability is greater than 0.5. It is the same. Look into this diagram, more than 0.5. So anything above 0.5. What was that just now? Who remember? I can't remember too.
7712.
1.7712. So 1.77 here. 1.77. Right? This is Z on the left hand side and the top 1.77. So what is the probability? Can you get the value of P from this table? Come on.
0.9616.
0.9616. So what's the probability of completing in 40 weeks? 0.9616. So you already have the answer. The probability of completing the project here within 40 weeks is 0.9616. What is the probability of delay more than 40 weeks? Can you work it out?
19.
0.113, 0.03.
Yes.
0.04. Okay, let me keep it simple. So it is very small probability that we can delay this one. So if you want to tender in any project or any project with high probability of completing, then you put you are very certain if you put 40 weeks, say you take a government job or whatever, you take 40 weeks and you are very, very confident you can complete it in time. In time is within the project durations, because the likelihood of delay is very, very small. Okay, let's look at another scenario. There's no 4 scenarios. What is the probability of completing the project in 35 weeks? Completing the project in 35 weeks. So X is
35.
X is 35. And then they say within, or that means within or in 35 weeks. So how do we look at the table? We are going to use this formula again. Z x minus mu over sigma. What do you get? Okay, I compute for you.
Yes.
Get this number. We get negative sign, right?
Yes, sir.
Negative
Yes.
0.44. If negative, that means we are going to look from right to left. We are going to look at the table from right to left. Okay. So 0.44, if we look at the table, what number do we get?
0.33.
0.44. Oh, someone already answered. So we have 0.67,
And then 1 minus
and then
0.67.
1 minus this one, because we are we are looking at the other way, that direction, right, brother? So we are actually the number we get just now is this probability, but we are interested the left hand side. So the answer is 0.33. 0.33. So 1 minus this one. So we are interested at this one is 0.33. This is the right answer. Any question? No question. Let's have another scenario. There are 4 questions. With 98% chance of completing the project in time, what is the completion time? 98% probability, what is X? If P is 0.98, what is X? That's actually, this is the questions. If P is 0.98, what is X? So what do? We are going to play with, so within X.
Look at the normal distribution table first and then get the Z value.
All right. So we look at the normal distribution, use P, look at the table. P, what was P just now? 98%. 98, right? P 98. What number do you want to use? This one? Let's use this one. Then look at Z, right, brother? Look at Z. So what do we have? Z 2.06.
Yes.
2.06. So we have 2.06. We have mu is 36. Sigma is 2.25. Can we find X? Simple mathematics, right, sisters, brother?
Yes, sir. We get
Correct.
51.
Yeah. What number do you get? 41. Okay. Let's have the last question. Last question. What was it? With 35% chance of completion, what is the project completion time? So this is the same way. No, P is 0.35. If I were to look at the table, I cannot find this number. The table only show more than 0.5. What do I do?
1 minus the P value because it's on the left.
Okay, 1 minus P value, because we're going to look at the right hand side. Move to the left, negative. Okay. So refer 0.65. So look at the table, 0.65. 0.65. 0.65. Where's 0.65? Somewhere here. 0.65 somewhere. What number should I use? Here, 0.65. So what is Z?
0.39.
0.39. 0.39. Okay, Z 0.39. So we are looking to the left, right? Just now. So it is negative Z. Negative Z, right? Agree? Now I
Yes.
insert the negative. Because we are looking at this side. But we are interested at this side. We are interested on this left-hand side. So can we compute X now? X minus 36. We can calculate this one. Okay, let me do for you. So we have X is 35.1. All right?
Right.
Yes.
Yes, not so difficult. Okay, let's. PERT is about this thing. The rest is the same, but mostly play around these 4 scenarios about probability. I think in exam also they ask you what is the probability of completing by what date, or given the date, what is the probability, depend. All right, we are done with this one. Let's look into another scenario. Where this scenario again, this is what you did last class. Look at activity B and look at the completion time, 52. Activity B, 10. If I were to reduce activity B by 2 weeks, I mean, I reduce to 8 weeks, what will be the completion time?
50.
50. If I were to reduce this by another 2 weeks, then it becomes 6 weeks. What will be the completion time?
48.
48.
48. If I were to reduce B to 6 weeks, what will be the completion time?
48.
48. Are you sure?
What, can you repeat? I don't hear you.
What if B were to be reduced, if activity B reduced to 6 weeks, what will be the completion time?
46.
46. Haha. Okay, anybody want to make another try? Okay, good try. Okay, let me play again. If I were to reduce this by 1 week, I reduce to 9 weeks, what would be the completion time?
51.
If I were to reduce to 8 weeks, this one?
50.
50. If I were to reduce to 9 weeks instead of 10, 7 weeks. If I were to reduce to 7 weeks, what would be the completion time?
49.
49. If I were to reduce to 6 weeks,
So just minus 4, so we get 48.
48. Okay, give another try. Can someone observe something first?
49.
49. Now we have another mathematics. 52 minus 4, 49. Brother, how do you get 49? I say I reduced it to 6 weeks. You say 49. How do you get it? 49? Still finding why. Look at activity A. What happened if I were to reduce this to 6 weeks? What will happen to activity A?
A will be repeated.
A will be critical, right?
Yes.
Yes. Just now, brother say 49. If I were to reduce activity B by 6 weeks, what happened to A? This one becomes 6. A become critical. B
Become 6 too.
B become non-critical. Agree?
Non-critical.
Non-critical. Okay, let's play this again. If I were to reduce activity B to 9 weeks, you have 51. Agree? If I were to reduce activity B by 8 weeks, become 52. Sorry, 50. If I were to reduce this to 7, what do you get here? If activity B is 7 weeks, what will happen here?
49.
49. So we have two critical activities. A and B become critical. Then if I were to reduce further by 1 week, so B reduced to 6 weeks, what happened to B? What happened to A?
A critical,
A critical, B
non-critical.
non-critical. So what will be the project durations? If I were to
49.
still 49. Now you get it. Good. So in any projects, there are situations when sometimes the client asks to reduce the project durations. Maybe here the client want to reduce this project by 4 weeks. So which one are you going to reduce? This is let's say we are going to lead into activity A. A we reduce by 1 week. It may no different to the completion time. Similarly, D also make no different. If we are going to reduce activity G, no different. So the best candidate to be reduced into our duration will be activity B, activity C, activity E, activity F, and activity H. And then all these activity have limit to be reduced. Some of the limit just now, if you reduce B, so that it doesn't affect others to become critical, how much can we reduce this B maximum? From 10 reduced to
7 only.
7.
7. I mean, we can reduce by 3 weeks only. Here, maybe depend on, sometimes it's not affected by the corresponding network. On its own, sometimes we cannot shorten anymore. Maybe 15 weeks, we can only shorten by one week or 2 weeks. Here, maybe we can shorten by 1 week maximum on its own, or if interdependent between corresponding, like here, activity D and E, I think maximum it can go 2 weeks. Say on its own, maybe because of resources constraint, I cannot, if say I am subcontractor doing activity E, or I can only reduce to 5 weeks, 4 weeks. The same go on this one. Yeah, although you have 4, you can go to up to, F, you can reduce by 4 weeks, and maybe I can reduce all of the 4 weeks. So we refer this as project crashing. Project crashing as a trade-off because of the request by a client to shorten the project. So it's a method for shortening a project duration by reducing the time of one or more of the critical project activities to a time that is less than normal activity time. So we call it crashing. It's not the house crash. I mean, crashing means shortening. So we are going to compute what we call it cost. So we are going to use this word, normal activity time, normal activity costs. That means if we are going to do certain normal time, we have specified costs. And then if we are going to shorten it, we may need to do some extra work. Maybe we do overtime, or maybe if construction we have to do at night. We need to reduce, say, noises. So we had to use another set of equipment. So the cost increase if we are going to shorten the project duration time because of say work at night and so on. So we need to increase our costs. So what we do, we are going to calculate our crash costs. So we are going to find crash cost per week, crash time, total crash costs, Because there are many other methods here. Here, very simple. Let's say we have a particular activity, where the normal completion time that we specify originally is 12 weeks. And our cost, say 3,000. If based on normal activity, 3,000. And somehow this particular activity can be reduced by 5 weeks. So we can crash it by 5 weeks. So we can crash it to 7 weeks, from 12 to 7. By doing so, our costs increase for extra work, extra overtime, extra resources. Our cost increased by 2,000. So it becomes 5,000. So we have crash activity time, crash activity, normal activity. So we have the duration, we have the cost. Now we are going to find the unit cost per week. So the crash cost per week, we are going to calculate 2,000 divided by 5. Very simple. 400 per week. That means this will be the additional cost above our normal cost. Okay, are you following? Okay, let's say, based on the project just now, let's say from our case just now, the client requests to reduce by 4 weeks. Then we analyze the crash cost. Let's say the crash cost, we have activity B. Then we analyze, it can be crashed by 3 weeks. And then activity C, this is a critical activity, it can be crashed by 3 weeks. Activity E can be crashed by, say, 1 week maximum. F, 3, and then H can be crashed maximum 2 weeks. So this is the maximum crashing. And then we already compute the crash cost per week. Let's say if you reduce this one, it costs 1,600 per week, let's say. And then this one say 2,000. The last one is 1,200, sorry, the middle one 2,000. And F 1,500. And then H will be 1,300. Okay. Situation like this. Now the client requests 4 weeks. And then this is your cost. And then you see the cost. Are you going to take any cost, or you want to use the cheapest cost? What's the candidate? Use the cheapest cost, right? The cheapest cost. So this is one of the cheapest. Which one is the cheapest? Activity E. You can crash by 1 week only. So you need how many more? You get out of 4, you get 1 already. Now you need another 3. So you want to use the most cheapest, the cheapest cost. What's the cheapest cost after this one? 1,300, right?
Yes.
1,300. So how many weeks you already get?
3 weeks.
2 weeks. Now we need another
Another
1 week. So what is another one? Which one you to use?
from F.
From F. So You use this 1 week, here 1 week, and here 2. So this is how we analyze. Let's say from here, your total cost will be 1,200 plus 1,005 plus 3,000. This is 2 weeks. This is per week. 3,000, 3, 4, 5, 5,000. So your crash cost will be how much? 3,
5,300.
5,300.
4,000.
5,800 or 3,000, 5,700, right?
Sir, may I ask?
Uh,
So for each course, for example,
okay,
1,600 is for 1 week only.
per week. This is crash cost per week after you
Oh.
calculate. This is the
Oh.
unit cost.
I thought we should be divide by 3 so that we get 1 week. Okay, never mind.
We already analyze, we already do the thing. So now let's look into our crash cost. This one sister say this is 2 weeks, so 1,300 times 2, 2006, 2006,
5,300, sir.
53. Okay, sorry, sister, it was 53. I think you are right. So this is the cost which you calculate for yourself. This is your cost, your cost. You are happy with this cost. So and when you see the client, okay, Mr. Client, I agree with this one. I can reduce by 4 weeks. My cost will increase by 20,000. You tell them this is your quote to your client. Then the client gets surprised. What? 20,000? And then they ask you to reduce. Then they ask you to reduce. Okay, for your sake, friend's sake, I can give you say 18,000. And then the client is happy with it. Let's say the client is very happy. You give a discount to 18,000. Are you happy? Your cost is 5,300. You give a quotation to your client 20,000. And then after bargaining, for this additional cost, then he is happy with 18,000. Are you happy with this additional work?
Yes.
Yes. Why? You make lots of money from changes, right?
Yes, sir.
Yes. So this is what's happening in most contracts. Whenever there are changes, the contractor will try to exploit this. This is how we make money from changes. That's why you hear news, contract price burst by so much, sound unreasonable. So you have some idea how it happened. You can do this using, of course, this is only a few weeks. In real life, it will be many activities to look at. They're very complex, involve many third parties, because each activity is not done by the same company. Maybe we have to subcontract to other parties, whether construction or even other consultancy. Not everybody is expert in one area, so we subcontract all these activities, and this will be the scenario. If there are so many activities, how are you going to reduce this one? Are you going to do one by one, check one by one? Maybe so much things to look at. So there's a method of using. We can use project crashing using linear programming, which we have not learned yet. So we look into the minimum cost if we are going to crash. Are we done? We are done. This is much faster than last class. So are we going to do, brothers, sisters? We have 25 minutes.
Sir, I want to ask.
Yeah.
So let's say, So crashing is like we reduce the number of the duration, right?
Yeah.
So for example, we want to reduce the time for we build a house.
Mhm.
So we calculate the cost is because maybe we have to bring in some more workers than
Yeah.
usual.
Yes.
Okay, okay.
Yes. Some workers more than usual, and maybe we have to work at night, extra hours at night. And when you have to do at night, like for example, some noise, we have to do some noise reduction. This just an example. Noise reduction, and we need certain way of reducing noises. So it incur additional costs. If you are a contractor, this is additional cost which you are not prepared to absorb. So you have to charge it to your client. So, so if
Oh, so
you
crashing is based on our client's wants, not because we want to cut it.
oh project, normally when you are having projects, let's say I ask you to do a house for me. I do not know how to do a house. So you are the contractor. So I already specified the house, say my architect already drawn the plan for the house, and I give it to you with all the information, say the structural informations, the electrical informations, the land size, the nature of the land, whether you have to do some earthwork or not. Say I have given it to you. And then I just want to know how much does it cost and how long can you complete my house? Of course, from there, then you, as a contractor, you have to call the different specialists, the carpenter, the plumber, the electricians, the steel worker to do the steel, the concrete worker. These are different set of team. It's not renovations. Let's say it's a major work. You need a different set of team, maybe different subcontractors. So by doing so, these people will give a price to you. And then you have to manage, you are project manager. Then only you start scheduling their different work activity. Once you start scheduling, you know who is critical, who is not critical. You know which contractor is critical, which contractor is not critical. That's why we analyze the slack. If you know this particular subcontractor is on the critical path, you keep an eye on this particular contractor. Then if he delay, then you start yelling at this guy. Why are you delay? You have to find a way to reduce your time. Otherwise, I penalize you. And then to make sure that the whole contract is within the period, because I am your client. So you agree with me to do a project within, say, 6 months, to complete my house in 6 months. So you cannot afford to delay. You delay, I penalize you. I mean, for certain penalty. You get the idea? It's your cost. The cost per week is your cost. And how much you charge me as a client, I do not know how you derive your cost. You are not going to charge me at cost. You are going to make money. You are a businessman, right? You are a businessman. You are not going to do charity. Charity, different thing. You do charity, a different thing. Not with me. Maybe from your profit, you may do charity, but you are not going to give away for me. Let's say. Do I answer you, brother?
Yes, sir. Thank you.
Welcome. Now I finish early. What should I do? Can I end the class?
I'm glad. I'm
Yes.
I'm okay with that, sir.
My pleasure, doctor.
Yes.
You're more than happy.
Doctor, I have a
Yeah.
question not related to the chapter, but to the course outline. Is that okay?
Again?
I have a question related to the course outline.
Okay, you want to discuss together or privately?
Just a quick one. So
Okay.
there's assignment and the group project, right? And the
Yeah, yes,
right?
yeah. I think we are not ready yet to give it to you. Not ready in the sense that not ready. Normally, we give this assignment after we finish this particular topic. In typical situation, after you complete your midterm exam, are you with me? In typical classes, all those assignment, we start giving you the brief after the final or just completing this particular topic. I mean, after project scheduling, and we start letting you know. And in most cases, in normal term, normal semester, we complete this project scheduling and then plus one topic. After that, midterm exam. After midterm exam, then we have midterm break. This is our normal thing. So if you feel you want the brief earlier, I can give you earlier, but I plan to give this brief to you after I complete this particular topic. That means after this week. Yeah, Aiman?
Yeah, sure. That sounds good.
Or you want earlier, then I just matter of 1 week. This is my typical way of this. By then, I think you have more feel about the course, especially when we already started the linear programming. Then you start feeling the excitement about this course.
All right, Doctor. Inshallah.
Okay. Any more? Any more question? Just know, brother, I'm more than happy to end the class. Shall I? Okay, let's end the class with the recitation of Suratul As. Bismillahirrahmanirrahim. Thank you very much, brothers and sisters. See you next class.
Inshallah.
Assalamualaikum warahmatullah.
Thank you, sir.
Thank you, sir.
Welcome.
Thank you,
You're
sir.
welcome.
Thank you, sir.
You're most
Good evening.
welcome. Yeah, welcome. Okay, I end now. Assalamualaikum.
Thank you, sir.
You're welcome.